Okay, so one of you could also become the co-organizer. Can I make somebody co-organizer so that we have two recordings instead of one? All right. So who can I make a co-organizer? Anand, Sukhvinder, Arun, Ashwin. All right. So I'm making Sukhvinder the co-organizer so that he can also start recording. Great. So have you started recording, Sukhvinder? Great, great. All right. So today we are going to discuss HDFS. This is the main component of Hadoop ecosystem, and I would like to pay a very detailed attention to HDFS. All right. All right. So in yesterday's class, we discussed about why do we need big data and why do we need these new genre of tool. In very simple words, after a certain size or after a certain complexity of the problem you're trying to solve or after a certain number of connections or the speed of data that need to be processed, you cannot handle you cannot handle with the normal system. And that's where you require distributed computing. Okay, so in simple words, whenever your problem requires big distributed computing, you call your problem as big data problem. All right, so to solve such kind of big data problems, we need different kind of solutions. Okay, and one of those is Hadoop. All right, one of those is Hadoop. So I would like to go into the detail about the basic building block of Hadoop called HDFS. All right. Now, instead of going the typical route, I would like to take a little digression and try to see how would it look to you, how would you solve the problem without using HDFS. All right. So imagine you have 100 terabyte of data or and you want to store this 100 terabyte of data somewhere. Where would you store such kind of data? How would you store 100 terabyte of data? Or let me rephrase the problem that you decided you're living in a hostel or you're living in a society where all of you decided to build a centralized storage which can store the movies up to 100 terabyte. How would you build such kind of system where all the people in your society or in the hostel can watch the movie and store the movie in this 100 terabyte store? So that's the question to all of you. How would you do it? All right. Anand says using a centralized server. Anybody else? All right. Thiru says that it's indexed folders. Asarfi says, okay. All right. Leela says using a distributed server. Brilliant. I want a little bit more details, Leela. And Sukhvinder says save on 10 computers with 10 terabyte hard disk with a server. Okay, brilliant, brilliant. All right. Abu says that divide the data into chunks and store it on remote desktops. All right. So, and Arun also says the exactly same thing. Divide into multiple chunks and use connected storage. Okay. All right. Maimona says that store it on the cloud. Brilliant. But here we are trying to build our own kind of a cloud. All right. We don't have that luxury of using someone else's cloud. Okay. Mohsin says that use many computers and have someone in charge to know where all data is stored. Brilliant. Okay. Mohammed says that using HDFS. Brilliant. Actually, that will be the last resort. I want to see how would you work out without HDFS. Mohsin says that each computer will have part of the data. Very great answers, very great answers. Now let's take your solution. I'm taking one of the most popular solution out of all of you, and that is probably most of you are pointing to something like this. Okay, what you do is you buy 100 hard disks or 100 drives, each with the storage of 1 terabyte data, and connect them somehow in the network. And when you connect them in the network, you mount these hard drives on some central network shared computer, or maybe multiple such folders in the network. Okay, so that when you access folder 1, it's pointing to the drive 1, and when you access the folder number 2, it's accessing the drive 2, and so on. All right. Now, do you see any problem with this kind of system? For a record, before before HDFS, we actually organized data in this form. And you would be surprised to know that most of the prestigious institutions as of today use a similar architecture where they connect many computers together, put a lot of hard disk inside these computers, and then mount these hard disks on on a common folder. All right, and also before you say that one of the problems with these is that there is no backup. Okay, so traditionally what we used to do is have two hard disks instead of one hard disk, and one of them is just a copy of the another, so that in case one hard disk uh, goes corrupted, or there is some hardware problem with one of the hard disks, there is a backup of that hard disk on the same computer. Now, do you see any problem with this kind of structure? Okay, let me come back to the question again. So we took 100 hard disks, connected them in a network, or maybe we took 200 hard disks, connected them in a network such that on each computer there are maybe 4 hard disks catering to 2 terabyte of data, because each disk is a copy of another. A redundancy of 2, that's what we did here. Okay, so do you see any problem with this kind of network? Anyone? So Rajiv says, what if some of the disk goes down? All right, all right, Rajiv, Maimona. You have a question for me? All right. Sukhvinder says that speed issue on the network. Brilliant. Brilliant. And okay. Arun says the cost is going to be an issue. Leela says, what if the network speed? So Leela says network speed could be a problem. Vishnu says disk access time will be more. Okay. Maimuna says that too much energy consumed. Ashwini says accessing of the data may be slower. Providing backup alone would double the cost of implementing solution. That's Suraj. All right. Brilliant insights. Okay. Very brilliant insights. So, as a matter of fact, the hard disks are not costly. Okay. The only problem with the hard disks is that they are unreliable. So, it's okay to buy twice number of hard disks. So, there are two, three problems you have outlined. Let me see if there are more. Mohsin says there will be problem accessing the data which is stored. Okay, okay. You mean to say that, all right. So Dare says that uniform distribution of the file size amongst computer. Brilliant, brilliant. And Mohsin's point is also very valid. Prasad says that there needs to be a way to manage the storage space across the hard disk so that it is best utilized. Brilliant. Brilliant. Sukhvinder says, what if all the users want to access the same movie? Brilliant. Probably this is the first time somebody has, hit the nail on the head of this problem, because this is something almost everybody misses. What if the users, all the users, let's say this is a birthday of some celebrated actor, or it's Independence Day and everybody wants to watch Independence Day movie, right? So in that case, that particular hard disk containing Independence Day movie is going to crash, or it will go overloaded and will not give you the throughput. Brilliant. All right. Prasant's point is very valid, that how would you make sure that the workload is equally distributed? Yes. Mohammed says the main server becomes the bottleneck. Yes. Multiple users accessing the same file drives. Billion Suras. Okay. So Leela is saying that I can't see all other audience chats except I can't see all other audience chat except for Sukhvinder. The problem is that I have made Sukhvinder one of the organizers. That's why you are able to see the chats with Sukhvinder. Okay. And I think only two guys are allowed to be the organizers. Asmit is saying CPU processing and RAM. Okay, okay, brilliant. So now, all right. So I think you all have answered the question, and let me reiterate whatever you have told just now. First, the problem is failover and backup. There's a difference between failover and backup. Failover means if something fails, something else will take over. While backup means in case something goes offline or something gets corrupted or get damaged, we have a backup from which we can recover the data. We'll not lose the data. But there'll be a human intervention required to bring the system back to life. Okay? So this system does not have failover or backup. For example, one of the computer is burnt and both the hard disks are gone, then the data is gone, right? Although by putting Maybe we can put redundancy on each hard disk by using a RAID. RAID is RAID, redundant array of independent drives. Okay, so if you put RAID means there are RAID 2, RAID 1. RAID 1 means there are two copies of each drive. Okay, there's one backup available. So even though we could try to do RAID, but RAID is not really greatly successful. And next is failover. What if the machine goes down? There is nobody else to cater the same data. Next problem is, how would you distribute the data uniformly? Okay, that's something I think only this batch for the first time has come up with all the challenges. Okay, so since we are putting data, so what we'll do is we'll say, let's say that we have got 100 drives, right? We've got 100 drives. We dedicate first two drives to A, second two drives to B, and so on. Now again, there are chances that there are too many movies starting with A, or there are too many movies starting with S. While so it'll be always a difficult scenario to distribute the files equally. Next is this the best value for money? 1 terabyte hard disk, you might be having the resources already in your organization. Is this the best value of money? We might have hundreds of hard drives, smaller size already available. Can't we utilize those? If we try to utilize those, then we'll have too many hard disks in the network, and again, the manageability goes haywire. We will have to manage the data in this new small hard disk as well. Or because we can't, if we have a smaller hard disk of say 20 GB, we can't store the data smaller bigger than 20 GB file, right? So the hard disk completely goes waste. If we are trying to store a file, say we are trying to store 80 GB Blu-ray, right? 80 GB Blu-ray we are trying to store in this file system, and our hard disk is smaller than that. We can't store it. Or hard disk has not 80 GB, hard disk has 70 GB space left. We won't be able to store 80 GB hard. So that space is left. Okay. So we will not be able to distribute data uniformly, and this is not the best value for money. What about increasing accessibility? This is the question which some of you, Arsuras and Sukhvinder, has answered. That what if all the users want to access the same file? And at least two more people have answered in this batch. And what about scaling out? Today we need 100 terabyte space. Tomorrow we might need 110 TB of space. Or tomorrow we might need 150 terabyte of space. Then does your solution requires too much of effort for migration from 100 TB to 150 terabytes? Okay, this is called scaling out. We are not scaling up, we are scaling out. Scaling up means instead of 1 terabyte, we remove 1 terabyte and put 2 terabytes. Okay, that again is too much of headache in this system. Hyperways. All right. So the question we are dealing here, Pervez, is about if you have to store 100 terabyte of data, you might build this kind of solution where all the computers are connected in the network and trying to save the data there. And that will suffer from these problems. All right. Now, so what exactly is the solution? In simple word, I'm trying to sell to you that HDFS will solve the problem as of now. Although there are few more systems on the lines of HDFS, but that we can discuss later. All right, so let's understand. So I hope everybody is now convinced that this HDFS thing is quite useful and we should learn about it. All right, to solve such kind of problem where you have to store humongous data such as 100 terabyte, we need a system like HDFS. Otherwise, we will get into the mess which we have just discussed. If we try to build, and mind it, before HDFS, this is how we used to manage our data, by connecting multiple hard disks and multiple computers together in the network. All right, so let's try to understand. I'm going to go step by step. First of all, the most important thing to understand about HDFS is it's composed of many computers. So we connect many computers together. We install HDFS services on these computers. One of these machines is designated as name node, while rest of them we designate as data node. Okay, so in the network there is one name node and rest are data nodes. Also, please keep in mind that you are free to install data node as well as name node on the same machine. And what are these in terms of computing? These are not hardware. Instead, these are processes. Just like a mail server running on your computer or somebody's server. Okay, in a similar way, these are computer programs. Name node is a computer program, is a network service listening on a particular port for the traffic coming in. Okay, similarly, data node is a process running on a computer listening for incoming traffic. All right, so we have got two kinds. So HDFS is composed of two kinds of services, name node and data node. Only one node is designated as name node, while rest are data nodes. Name node is like the king or the central agency. As you some of you had pointed out, that somebody has to keep track of which file is where. If we are storing it in the previous architecture where there were so many computers, we have divided the files into the multiple computers. Somebody has to keep a track of what is where, right? Somebody has to keep this this kind of journal, this kind of accounting, that which data is located on which computer and which hard disk, and data node store the actual data. All right, so you can think of admin node as just the entry in an Excel sheet, and you have marked that, okay, first this data is on this computer with this IP address. This data is on this computer and that IP address. All right, so that is name node. So name node keeps the index of what is where. And this is called metadata. Metadata means name of the file, name of the folder, name of the parent folder, and for every information, like for if you it is a folder, who is the parent folder and so on, the full information about the file system, about which file, which folder, how many folders, how many files, what's the file size, what's the name of the file, and what's the attribute, like who is allowed to access which file. All of this is called as metadata, and all of this is maintained by name node. Okay, name node is a service. Okay, as I told you, it's like a Windows service which is running in the background listening on a particular port for the traffic to come in, just like just like an email server which is listening on a particular port and waiting for the traffic to come in, similar to the HTTP web server which listens to 80 port. Okay, email server listens to 25 port, and here the name node listens on 8020 port. Okay, if I'm not correct, if I'm not wrong, it would be 8020. Okay, so name node and data node listens on 8030. So basically, these are just the services listening on certain ports. All right. All right. So I have some of your questions, and let me just describe these three features of HDFS and then answer your questions. Most likely, your question will be answered by then. Okay. Name node keeps all of the data in the RAM, although it keeps a copy in the disk. Okay. So name node keeps the data in the RAM, all right, although it keeps backup copy, but whatever is the metadata it'll keep in the memory so that it can quickly serve. Now you can think of this structure that name node should be run on a computer which is having big RAM, big memory, and data node should be run on a computer which has got bigger disk. All right, now let me take a step further. While storing data into data node, the files are cut into 128 MB blocks. Except for the last block, all blocks would be of the size 128 MB. The last block might be lesser than 128 MB, but it only stores the amount of data which is there. In case you have 130 MB data, there'll be two blocks, one of 128 MB and second one is of 2 MB. It does second block will not consume 120 MB storage. There is no buffer or offset. Okay, so the files are broken into the blocks of 128 MB. Earlier, and in some of the systems still, this size is 64 MB. That's a design decision which Hortonworks has taken. So we are going ahead with 128 MB on our CloudX lab. Okay, on our CloudX lab, the default size of a file is 128 MB, default size of the block. So we break the file into the blocks of 128 MB. So if we have 1 GB file, there'll be 8 blocks, 8 pieces of this file. Okay, all right. So why do we do that? It helps us fitting big files into smaller disks. Second, it leaves less unused space on every data node. Okay, and it optimizes the transfer of the files. Okay, and moreover, in case there is one file which is distributed on 10 blocks or 10 data nodes, whenever user is accessing the file, the load will go to 10 machine, not only one machine. And that's how it distributes the load to multiple machines. All right. Okay. One more thing I want to say before we go further is every block. So we talked about few things. First, HDFS is composed of two different kind of services. One machine has been designated as the master and called name node, and rest of the machines are called, or rest of the machines are called data node, where data node stores the actual data, what is inside the file. So data node does not know the name of the file, while name node does not know what is inside the file. So that's how it is. Everything to do with file name, folder name, attributes, and everything, folder structure and everything, which is not the actual data, which is the metadata, is stored on name node. Okay, so then we talked about then we talked about that each file is broken down into blocks, and that's very useful. Just like when you download a big movie using a torrent, that file is broken down into pieces, and these pieces come from multiple machines parallelly, and it helps downloading parallelly as well as it helps us balancing the load. So there are many more benefits of breaking down a big file into blocks. Okay. Next is It's like building a house with small bricks, because you can't build just a big house with a very big bricks. So although that's a bad analogy, but it should give you an idea. Second is, every block has multiple copies. Okay, so we have broken down a big file into small blocks, and every block has got the default copies as 3. You can change this default setting of HDFS to anything you want, but I would recommend personally that keep it 3. I'll give you the reasoning behind keeping 3 copies. Okay, so every block, whatever we have sliced it earlier, gets 3 copies. Okay, one on one node, second on another node, and third on some other node. Generally, first 2 copies are on the same rack, and the third one is off the rack, some other computer in the network. And rack means an almirah in which you stack the computers such that these computers are in the same local area network. Okay, so 2 computers which are closest to each other are generally connected in the rack. So an almirah is called a rack in a data center. So first 2 copies are on the same rack, and third one is off the rack. All right. So each block has multiple copies, and this is called a replication factor. By default, the replication factor for a file system is 3. You can change the replication factor of each separate file, as well as you can set the default replication factor of the file in a file system, so that if you don't like the idea of 3 replication factor for each file, you can set it to something else. As well as, if for some file which are not very important, you can change it to lower, and for some files which are very important to you, you can increase the replication factor. All right, and in case one of the data node goes haywire or is get burns down, you have 2 more copies of each block that get lost, right? Because every block has 2 more copies somewhere on another computer, and in case one of the data node goes down, you have 2 more copies lying around in somewhere in the network. At that point of time, name node will instruct those nodes having those 2 backup copies to start copying them, such that every block again regains the 3 replication factor. Make sense to you? All right. So we talked about replication, we talked about blocks, and we talked about name node and data node. All right. So one more thing I would like to say before I take up your question. All right. So as it sounds that the user will only talk to name node, that's what we studied so far. In all our architecture diagrams, everywhere it was something like we choose a leader and leader talks to everybody in a network. No, in this case, no. Name node is only accessed once by the user when they're looking for the file. Okay, and afterwards, once the user gets all the information about which block is on which machine and which copy is on which machine, then the user directly goes to the individual data node. So you can see here, the user for the first time comes to the name node and says, hey, I want to read the file or create a file or update a file. Name node says, hey, don't bother me, go directly to the data node. Either you want to read or write, you talk to the data node, and once you are done reading, once you're done writing, just let me know. In case you are reading, don't come back and don't bother me, I'm a very busy person. Okay, the reason is name node is a high traffic one. The reason why name node keeps everything in the RAM is so that it can cater to all the needs. And HDFS makes sure that no 2 people try to intervene in the same file at the same time by the use of a singular name node. If there are multiple name node, what would happen is some user went to one name node, some other user went to another name node, and effectively they will corrupt the file system. Here, there's a strong consistency. There's a strong consistency. There could not be two writers at the same time. Name node will block it. All right. So the client driver comes to the name node and says, hey, I want to read the data. Name node says, okay, which file do you want to read? This file. This file has got these many blocks. These blocks are located on these data nodes. Why don't you choose by yourself which copy of the block you want to read? And it's up to you. It's up to the driver whether it wants to read it parallelly or sequentially. Okay, and this is not done by you as a user. This is done by either the client you have created by writing the API or the command line you can use upfront. If if you are building a video streaming service, you will read block by block, one block from one machine, and then stream that block to the end user. The end user will watch the movie, that particular block, and then you start reading the block from another machine, and so on. In case, in case you want to quickly stitch the data, you might want to read all of this data together from all the machines. You might want to create your own driver. Okay, so this driver, the client driver, is generally the command line called Hadoop FS. There is a command line I'll show you today. There is a command line called Hadoop FS, or there could be the API or the web interface, okay, that you are using. So user uses client driver goes to the name node for first interaction to find out the metadata, and then goes to individual data node. So you can see that name node has cleverly avoided itself from becoming the bottleneck. All right. Now you can see that name node is avoiding itself from becoming the bottleneck in these manners. All right. Now let me just start making notes. All right. So all right. So first question is, will there be contingent name node? We will talk about this quickly. That's Thiru. Similarly, we have Rajiv's question. Uh, we have two name nodes? We do, but one of them will act like passive copy. Okay. Sneha, were you able to see the screen? All right. Another question is from Arun. So can we have all data nodes and name nodes on a single machine, and still will it be called distributed computing? Okay, let me answer it both the parts separately. Yes, you can have one data node and one name node, okay, on a single machine and still be called distributed computing. No, it is just simulation, or it is just pseudo. It's not it's not really distributed computing. Next question from Anand is, do HDFS fail if machine which contains name node fails? I would like to park it with these questions. Okay, I would like to park it with these questions because these are very important questions and I want to take it together. All right. Next question with from Parvez is, machines with special hardware is required to make name node? No. Any machine can be the any machine can be the okay can be the name node. Yes, Ashwin and Maimona, you've raised your hand. You have any questions for me? You can ask from the in the questions window. All right. Same question from Sukhvinder. Seems to be a complex setup. Okay. Is there any requirement? Let me. Okay. All right. The question from Rajiv is, can we change ports for name nodes? What if already some other service is running? Yes, we can change the ports. Okay, but as a matter of fact, when you change the port, every time you access name node, you will have to specify everywhere that, hey, it's not 8020, it's something else. Okay, another question is from Abu, that what are the specs in terms of operating system and hardware? All right, question from Prabhu is, what if number of data node is less than size of the file divided by 128 MB? Okay, good question. Good question. I'll answer this in one. Okay, what are the capacity of data node machines? Okay, then we have very brilliant questions. Okay, so you can see all the questions now. All right, I'll come back to the name node failure part because that's a little complex and good. Good. Very great set of questions, and every question need to be, we should pay a great attention to every question. Okay, some of the questions here are, okay, what are the hardware specifications required for name node? Okay, and in terms of operating system and hardware requirement, let me go back to this question first. Okay, so in case of distributed computing, specifically in terms of Hadoop, most of these softwares run great on commodity hardware. You do not require very special hardware for even storing humongous data. Data nodes can have different sizes of hard disks. Some of them could have 100 terabyte, some of them could be 50 terabytes hard disk, and so on. Sorry, 50 gigabytes of hard disk, not I'm talking about gigabytes. There's no terabyte beyond 2 terabytes hard disk. There's no point in buying those. Unlike if you talk to a traditional IT manager in an organization, the first thing you will notice about them is the pride we took, the pride they take in saying that we have just purchased a 20 terabytes storage computer. They purchased 20 terabytes of storage, but the read speed is that of equal to that of 500 gigabyte hard disk, or maybe slightly faster. Had they bought so many hard disks, they could have got so many times reading speed, right? So here, in case of Hadoop, you do not generally require a very high-end system. But in case of name node, since it it keeps the data in the memory, it keeps the data in the memory. You might have to, since it keeps the data in the memory, you might have to have a bigger RAM for the name node. So generally, for the name node, it is strongly recommended that the RAM is bigger than 8 gigabyte. Okay, for data node, it's okay to have 4 gigabyte of RAM. And with respect to CPU and everything, it's completely okay to have any kind of a setup. The most important part to understand is, as of today, the way Hadoop has been designed, that it wants the same architecture on all the nodes. Similarly, operating system on all the nodes has to be on the same version number, as well as you cannot have name node running Red Hat Linux, and data node running some other operating system. As of now, if you try to, although theoretically they say it's possible to install Windows and mix these systems, but no. Right now, when I try to install, it says clearly that you have to have same operating system on all data node and name node. All right. So, and good news is that now, as of now, the Hadoop is available on Windows as well. Okay, but you cannot mix and match Linux and Windows. So Hadoop is as of now available on both Red Hat, I mean, available on the Linux machine as well as the Windows machine. On Linux machines can run on all flavors of Linux. Okay, so that answers the first question. All right, and now, what if number of data node is less than the size of the file divided by 128 MB? That's completely okay. So, two blocks of a file can be on the same machine. Okay, but two copies, two copies of a block can't be on same machine. So probably your question would be can also be looked at from the another angle. Can there be a situation that you have increased the replication factor to 5 and you only have two data nodes? In that case, it will show always HDFS will remain unhealthy. It will show that we are not able to reach to the replication level as promised, because two copies of each block cannot be cannot be on the same machine, and therefore if you say that I want replication factor of 3, you should have at least 3 data node. Okay, so you cannot have 3 copies of a block without having 3 data nodes. I'll show you this. Please remind me to give you this demo. How it is ensured that there is no data loss while splitting the file. The driver does it. Okay, driver is a good software. This driver, client driver, in this design of the client driver, you have to make sure the data splitting is done correctly and stitching is also done correctly. It's not the headache. Stitching and splitting is not the headache of Hadoop. It's the headache of this client driver. Hadoop only says that please store the data from 0th byte to 120th megabyte on the first block on this machine. So that's it. If client driver fails to give that, It's not Hadoop's problem. Hadoop will just reject that file completely and say file writing failed. All right, very brilliant questions. It's great to have uh, good student in the class to have such great questions. Does this mean that the nodes containing the copies of the same data would be placed on different disks? It'll be different data nodes, okay, not only different disks. Since each file is saved on multiple data nodes in 128 MB files, client has to access multiple node at the same time. Maybe and maybe not. Maybe, okay, it depends on the client. Okay, by default, the default client we have, it accesses the data sequentially or parallelly. It can that I'm not sure, the default client, so that it can read the data from multiple data node, stitch it together and give it to the user. Okay, it's up to the client driver how it is programmed. Ideally it should access all the nodes in parallel, so that so that all of the data comes together, so that we the overall time is faster. All right, so another question is, I'll just talk about the name node backups after this. After the client does its processing of read or write, how will name node know whether the action has been completed? So when the client starts writing or changing anything, it informs namenode that, hey, I want to create a new file with this name, and namenode will make a temporary entry, so that if somebody comes parallelly and tries to create the same file, it'll say, no, 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 there's somebody else trying to create the same file, so your changes will not be accepted unless there is a commit from the driver, or driver has lost the connection, and afterwards this temporary file will expire and will be deleted. Okay, so driver makes an entry with the name node that, hey, I'm going to write this file. It's a temporary entry. In case client driver does not report back to name node, okay, name node will discard those changes and inform the data node also that if you have made any changes, delete the data, because looks like client driver forgets to commit to the name node. Maybe the data has been written only partially. Okay, that's how it makes sure the data has been written successfully. Okay, if you want to store 100 terabyte in HDFS, then do we need 100 terabyte of space on HDFS? Because of replication factor, we need 300 terabyte plus metadata. Okay, that's the space you need. Not 400, but 300. Yes, on the bottleneck slide, it shows that the client is talking to data node directly, as well as name node is talking to all the data nodes just to keep the heartbeats up. The way, so here, if you notice when we talk about this, in case any of the data node goes down, name node will not receive heartbeats as in ping. Okay, the way I keep my session alive is my client will keep on informing the server that, hey, I'm up. If there is a network disconnectivity, server will not receive information from me and server will assume that I have got disconnected. Similarly, if data node does not give pings to name node after a while when it does not receive the pings for quite some time, will assume that the data node is down or dead, and it will start the replication process. All right. In the bottleneck slide, okay, so that's it. What if the name node fails? This is a very big question. So many of you have the same question. I will cover it slowly, slowly. Okay. Could you provide an example when we want to read the data together, unlike streaming? Okay. All right. So whenever somebody a user wants the full file, whenever the user wants the full file, so what will you do is you will open the data connection. The client driver will open the data connection to all the nodes having the blocks that are required. Okay. And then while one block is coming from one server, other block is coming from other server. So both the things are happening in parallel. Okay. So we are not waiting to start the second copying um, before the first one has finished. Okay, so after the first one has finished, we are not doing that, we are doing it parallel so that everything becomes faster. Okay, so that's an example. In one of the earlier slide you wrote the data remains in the memory. Did you mean for metadata? Yes, I meant for the metadata in the name node. How can multiple users access the same data in HDFS? Of course, the name node allows multiple readers of the file. Just that if somebody is writing a file, it won't allow the readers to go in. Okay, because everybody seeks the pass from name node and then it starts talking directly to the data node. All right, those are the brilliant questions, and let me check if there are more questions related to the things which you have discussed so far. Okay, so question from there is how does the file get to Hadoop initially before we even think of distributing file? Okay, so the way it happens is, I'll try to show you from here. Okay, so there is this user who is having a command called Hadoop FS. They will use that command to to upload the file into the cluster. Okay, so this client will talk to the name node and say that, hey, I want to upload the data. This is the name of the file, this is the file size, and these are the attributes. Could you create a temporary entry for me so that I, okay, so once name node says okay fine, I have made a temporary entry. Okay, and once you are done with writing, once name node is saying that once you are done with writing, please come back and let me know. Okay, so this client will direct whatever list of the name data nodes name node has given to the client, saying can you go to these three data nodes and store these blocks on these data nodes. So name node will tell the client driver to do that, and this client driver will talk to that particular data node and will start copying the data there. And once it is done copying the data there on that data node, it will inform the name node that, hey, I'm done. Can you mark it committed? That's how the data goes into Hadoop initially. So I'll show you this by using the commands, and then the things will get clear in case you're asking about the command. All right. All right. So Prabhu's question is very important. Is there any order in which data nodes is chosen to save data in the blocks? First copy of your blocks are actually stored on the local data node. So in case This, in case you are standing on one of the data nodes and you are transferring the file from the local file system. Okay, so you can imagine this way, that every machine called data node or name node, every machine has got local file system as well as a folder reserved for storing blocks. Okay, so on a machine, when you are trying to copy the data, it's actually handing over the file, blocks of files, to data node, right? To data node, and data node is running locally. And if you are one of those nodes like H5, right now H5 is one of those data nodes where you will log in and see what is there. And when you do that, so uploading a file on H5 or H1, H2 or ABC in the CloudX Lab is equivalent to just copying the file from one folder to another, because data node is running on the same machine on which the client is standing. Therefore, the first copy of the data goes to the local data node. And this data node will then start propagating the other copies in the network until it reaches the replication level. All right. So the order is first copy in local node if you are on inside the data. Okay. Second copy to the node on the same rack. Okay. Third copy is of the rack. Okay, a rack is a rack inside a server room on which multiple computers are kept, and every rack has got a hub onto every computer is plugged in, such that all these computers are in the same subnet or same local area network. So the connectivity between one computer to another on the same rack is extremely fast. Yes, one rack could have different data nodes. That's a question from Asmeet. Okay, Anand's question is, what by client do we mean Java? No, by client we mean some client written in Java or some other language which can talk to the server, which is data node or name node. They can talk to directly over the socket and execute. Okay, by client, by default there is a client which is written in Java called Hadoop FS, which is locally available on every node. If you want, you can create your own client. If you want to develop a client, although you would not need one. All right, next question from Vishnu is, how is read write? Okay, a question from Anand is, how is not this one, Vishnu is, how is read write operation handled when these operations happen simultaneously on the file? How do read write operations handled when these operations happen simultaneously on same file? So the way it happens is, name node, since it favors strong consistency, if there is a writer writing a file, same file, if writer is appending a file or updating a file or creating a file, it won't allow any reader on that file. Okay. Similarly, if the users are a lot of readers are reading the same file, it won't allow writer. Writer will wait till the readers have finished. Although if there is already somebody reading the file, it would allow other nodes to other clients to read the same file. That's how it is handled. Okay. No reader and writer together. Okay, or no, to writer is also not possible, while reader plus reader is possible. This is okay. Wow, these are great questions. Prabhu's question is, can you give example of how data and slash info is communicated between client driver and data node and name node, also where bidirectional communication is possible. Okay, so the example here is that if you go to any of these nodes, you could basically, okay, all right. So that will be little difficult for the current class. This, I think, we can keep it for offline. This is a good question because it's a network protocol thing. Okay, so these communication happen over the network. Okay, over the port. So it's like you connect to a port, you read some data, give the ACK, and so on. Okay, so I don't have because that would require me to a little bit do a little more hard work. So I'll just put it into to-do list. Okay, all right, that's my to-do list at the top of the file, and I'll just go to the end of the file for writing. Hi Ashok. Okay, good. So don't worry about the questions. It's okay. It's perfectly great. And it's good to go through other people's question because you would have the same question in mind, just that you are not articulating at this point. All right. So it's great to have these questions now than later. All right. All right. I'm completely okay in extending the class for a couple of more weekends. Okay. But no question should go unanswered. Every question deserves an answer. Yes, I can see your chat, Ashok. It's just that there are too many questions, so I have to, you know, skip some of the things which are not questions. Okay, it'll take me some time to. All right, here is a question from Ashwini. Yes, Ashwini and Maimuna and Sneha, you've raised your hand. You have a question for me? Okay, so let me answer a few more questions. All right. So Ashwini's question is, part A of some XYZ movie will get stored in only one data node. Yes. So let me just say, let's say you have 1.1 gigabyte movie. Okay. So we can say that there will be 8 blocks of 128 MB each and one block of 100 MB. So you can write it this way: 8 into 8 into 108 MB, 128 MB. So the blocks will look like this. Okay, and one block of 108 MB. Okay, now these blocks would be on the same on this local computer first, on the same data node as the driver, because that's the closest to you. So generally, the first copy goes to the data node, which is very closest to you. And if you are standing on the data node itself, then the copying happens to the local node itself. And then each block will be replicated to two more nodes. Okay? Okay, depending on, in case the local node is not free and it has already full hard disk, there may not be, all the blocks may not go to the local node. All right. Parvez's question is, can the database server act as a data node? No. It demands it basically, since every block is stored in the local file system, it's impossible. It does not allow the database server to act as a data node. All right. Maybe they have some feature which I may not be aware of. Okay. Ashwini, did you get the answer? All right. There is one question from Asmeet. Question is, if different user want to write in different file, the name node says yes or no. Okay. If different users are writing to different files, it is yes. Okay. Because it doesn't matter. You can keep on writing multiple files. It doesn't matter. Okay. So it's not a universal global lock that if any of the file is being written, then other files cannot be written. If you are writing two different files with two different folder names or the file name, it will allow them. Yes, Ashok, I'm able to hear you. I'm able to see your chats. All right. Now, Arun's question is, are Scoop and Flume considered client for loading data into HDFS? Okay. Yes, they are also considered as the clients to load data into HDFS. They are highly distributed. We will go into the details and we'll also talk about examples of each one. Vijay's question is, when many users want to access the same file, how HDFS addressing such a high demand file? Okay, so this is a very good question. Okay, let me try to explain this question. Question is, when many users want the same file, okay, how is HDFS addressing the high demand? Okay, so each block is at maybe multiple machines, and each file has multiple blocks. So if there is a, say, if the users are trying to watch the same movie, let's say me and you want to watch Independence Day movie because it's Independence Day, and just that I started watching the movie 10 minutes before you. So I'll be reading the first block, I'll be reading the second block, and you might be reading the first block. So first parallelism happens because of breaking the file into blocks. So because we broke down the file into blocks, so multiple users could access different blocks from different machines. Second redundancy or second parallelism happens when, because of second parallelism happens because of each block having three copies. So three users can access the same file parallelly without having to worry. So name node keeps track of how many readers are reading each block and keeps informing the new readers. and new readers can take into that account and read from lowest traffic data node, and hence they can all read from it. Okay, and one more thing I would like to emphasize here. There are the few added features in Cubole Cubole kind of file system. There are these uh, secondary, these layers on top of HDFS provided by companies like Cubole. What they do is, when the server notices a surge of demand of a file, it increases the replication factor. Okay, so increase increase replication for file in demand. Okay, that's another layer, and that's good to have in case you are building a video service. All right, so question from Ashwini is, client driver is just an interface or software program, or it is a separate machine? It is just a software. It's just a software. It is not even a service. It's a binary, or it's a Java API, or a software interface. Brilliant. So you got it right. Vijay's question is, how HDFS is bringing efficiencies. Yes. So did you was I able to answer your question in this? And yes, your follow-up question is also brilliant, Vijay. And Qbol replication is temporary. Yes. Okay, and this I came to know from one of my co-instructors, Swati, who works with us. Who just gives the training sometimes when there are many people. So, yeah. All right. Though I have not used Qbol yet. Good. All right. Generally, in big data, is write once and read many times. What is the situation when we want to update a file? Brilliant. Good question. So, the way HDFS has been designed for the situation, for basically mostly append only. Similar to normal file system. If you have a normal file system, if you try to modify even a single bit, you end up rewriting the whole file. If you open a file in a text editor and then you modify some lines in it and then press Ctrl S, it actually overwrites the existing file from scratch. Or it creates a fresh file and deletes the previous one, either of the two. In the same way, in HDFS also, HDFS has not been designed HDFS has not been designed to handle high amount of updates on a file. If you have lot of modifications inside a file, you may have to reevaluate your choice. And for the circumstances where you have to modify a file very often, you may want to go for a system like HBase, where every row, every cell of the database could be edited parallelly without having to worry. Okay, multiple rows could be edited. If you have to have an efficient updation of the data, then file system is not your choice. File system or HDFS is great when you want to create a fresh file and keep on appending to it or keep on reading to it. Okay. So Rajiv's question is, my connection was down for 1 minute. I'm sorry, but could you please take that question of 400 terabyte replication, I see that you have written 300 TB plus metadata. But is it because one copy goes to the offline? No. So the copy which goes to the same machine on which I'm standing right now, on which your driver is there, because every node generally contains one data node. If you have 50 node in your network, you will generally install data node on all machines, and you will be surprised that we ourselves have name node and data node on the same machine. Okay, because we realize that we are wasting that disk. Okay, data node does not utilize that much RAM, while name node utilizes RAM and does not utilize disk. So it's okay, in my opinion, to have name node and data node on the same machine. So we have five machines, so we have five data nodes and one name node on A. We have we call our servers as A, B, C, D, E, and we also have the same name like H1, H2, H3 for all the nodes. Okay, so so because when we say replication factor of 3, that means 3 copies. It does not mean 4 copies. Okay? And I'm not counting your offline data, the data which is there while copying into HDFS. Because as soon as you finish copying the data, you should delete that data. As soon as you have moved the data to HDFS, just remove it. Okay, so we are not counting that the source information from which you are copying the data. And generally, when you're dealing with humongous data, you do not copy the data to HDFS. Instead, you move the data to HDFS. And the laws of handling big data, you will notice as we go ahead that laws of handling the data are are little bit different. For example, when you have humongous data, you don't copy around the data. You basically move the data from local files to HDFS, because copying the data may prove to be very costly. All right, so it'll be for, if you have copied 100 terabyte data onto a Hadoop cluster having 3 replication factor, then it'll consume 300 terabyte of storage plus a little bit for metadata. A question from Mohsin: is the user client allowed to decide on which available nodes the data gets stored? No. It is dictated, dictated by name node. All right. Sneha's question is, if user A is reading one file and user B wants to write another file, yes, as long as they are not trying to modify the same file, or one user is trying to modify a file, there won't be any problem at all. Okay, I am writing the one file, you are writing some other file, it's very much okay with HDFS or name node. All right, great, very great set of questions. And all of you should pay close attention to these questions, because these are the questions I prefer to ask in interviews when I generally am interviewing somebody on HDFS. Okay. Suraj is saying, every time a file or data is updated or modified, would all copies of data as well as metadata in the name node be updated? So I'll try to explain this. This is a very brilliant question. So when you modify a file in HDFS, it's equivalent to abandoning or deleting the existing blocks and rewriting the whole file. It might sound like a disaster to you, but that's how HDFS keeps the sanity of the files. Okay, so if you're modifying a file It's equivalent to deleting a file and creating a fresh one. And in case your application is trying to modify a file very frequently, you need to evaluate your choices of solution. You might want to go with HBase. All right. You might want to go with HBase. So Vijay's question is, so for example, Netflix, if they know the users are in thousand, then it means they have to do thousands of replication so that people can watch it at the same time. Yes. They will also do multiple kinds of optimization. They will cache a file which is very popular and serve it right away from the memory instead of traveling till the disk. Okay. Parvez's question is there any extended HDFS concept like extended replication architecture? Brilliant. Yes. I would like to get into the detail after some time. Yes, recreating a file will be overhead. Yes, that's true. But in case of HDFS, that's a design choice which has been taken. All right. So HDFS is great for append only files. Append only files. If you're trying to modify, it's equivalent to recreating the file. All right. So very brilliant set of questions. The questions which are not answered is these ones related to name node failure. All right. I hope I have answered your other questions so far, except for the name node failure. Yeah. All right. Now, this we have already discussed. The client comes to write a block. First copy goes to the first node, and the second copy might go to another rack, but the replication happens between the data node. It does not come back to the client. Similarly, the client wants to read the data. First, it goes to name node, gets the metadata information about where is the block, and then accesses the data node. Same thing what we have discussed earlier about HDFS, the hops that are involved in creating a file. So HDFS client comes in, talks to the file system, and then so here this client is trying to create a file. Then it goes to the name node, says, hey, I want to create the file. Name node says, okay, fine, you go to the data node and create the file. Now HDFS client opens a file data stream, which is basically opening the stream to the first data node, or this data node which is the closest to this machine. Generally, this HDFS client, if you are standing on the same data node, then you will directly open the local file system connection, and then you write the data there. And effectively, you'll be able to quickly write the data there, and then the copying of the data starts parallelly between the data nodes. Name node will inform data node that, hey, since the user is writing the data to you, why don't you start parallelly copying to other data nodes? Okay, and once the first copy is written, a confirmation is given to the HDFS client saying that I have written the data, you can confirm to the name node. Now the client will go to the name node and say, hey, I'm done with creating the file. Your data node has said successful, so I'm done. And then the name node says, okay, fine, the entry you have made, I'm marking it committed after confirming with data nodes. Okay, so name node does not take only the word of HDFS client, it also talks to HDFS data node and ask him that, hey, is it true that this file has been successfully written? He says yes. Okay, that's how it maintains the sanity of the file, right? And in the case of file read, the first call goes to the name node. Name node gives the block locations, where is which block, and then the HDFS client accesses those data blocks from these data nodes, because and out of the multiple copies of the block, it accesses the copy which is near to it, and also which is comparatively free. All right, then we will talk about how the single point of failure is avoided in the second half. All right, very great set of questions. Do not lose this kind of questioning tendency, because the only way to learn is by questioning. All right, break for 10 minutes and we will be back by 10 o 11 p.m. IST. Okay. All right, so can we start now? Is everybody back? Should we start now? All right. I missed one question from Sukhvinder. Question is, when we say local data node, that means client driver machine or the nearest data node. It's nearest data node. Okay. All right. Great. So we have everybody's back. So now let's try to answer the question which probably many of you are waiting for. Yes. So name node we talked about, and many of you have already asked, what happens in case name node is shut down? Since name node is singular, and what if the hardware burns at the name node level? What happens in those cases? Okay, so name node keeps a backup of namespace, as in the full memory, as in what are the folders, what are the files, and everything. It keeps a backup copy of the whole memory image along with edit nodes on two locations. It can keep that on two locations. It can keep in a local storage as well as in a network file system. So in case the name node goes down, you can get the data from either the network file system or maybe the local storage. So this is a bad way of recovery, because here you will have to have a manual intervention to bring back the name node. Okay, so that's the first way of recovering from the name node failure. It is a backup, but not is a it's not a failover. Okay, it's not a failover because okay, the second one is called the secondary name node. Okay, in case of secondary name node is keeping two copies of the backup, one in the local storage, two copies of metadata in the local storage, although it keeps in the memory as well. So it keeps the edit log and the image of the memory, because the way most of these systems work is they periodically saves the complete image into the disk, and then as and when there is a change happening, it keeps on adding more and more records. Okay, those are called edit logs. So it's like periodically they purge the whole image into the disk, and afterwards all the changes that are happening, it keeps on making add entry in the edit logs. Okay, so these edit logs plus image as in namespace image, these two things can be stored in the local are stored on the local storage, as well as you could have something called secondary name node. But the problem with the secondary name node, though it sounds like it's ready to be served, no, it just you have to bring secondary name node up to the speed of name node, and then you bring it up. Otherwise, so you have to manually brought up the secondary name node to the latest image, and in case of emergency. Okay, all right, the best way to have better availability of name node is by using a backup name node or standby name node. It's called backup name node or standby name node. So name node, although it remains a single point of contact, it has a copy, a mirror image of itself called standby or backup name node. So this is another architecture. So you can choose any of the three. I prefer this one. You have name node and you have standby. In case name node goes down, immediately standby will be brought to life automatically. Okay, and the way it happens is actually quite interesting. This started happening in Hadoop 2.0. Okay, it's also called quorum, quorum general manager for high availability. So all the data nodes know about both of the name node as well as standby. Similarly, name node knows about standby. So every time name node makes a change, it informs the standby. Similarly, every time data node and wants to talk to name node, it also informs standby. So the the job of keeping standby updated is of everybody, not only name node. So everybody who wants to update name node also informs standby. Okay, so this model is called quorum general manager, using quorum general manager. And the moment system guesses that okay, name node is down, immediately standby becomes the main point of contact. And this switching could happen using something called zookeeper, and there are few more models. All right, so now the fourth level of backup. Imagine, so this was up to the point where name node could fail. Now there could be another problem with the name node. Okay, there could be another problem, and the problem is, what if the memory is insufficient? You have got too many files to store, and name node's memory is not allowing, and it's becoming the bottleneck. The RAM is becoming the bottleneck. So what do you do in that case? Okay, first, if you have too many small files, the best way to store in HDFS is club them together using a tar format or a zip format, and then store those all files in HDFS as a single file. Okay, or you create something called sequence file. It's a format provided by Hadoop, so that you can combine all the files into a single file, into called something called a format called sequence file, and then you hand over to Hadoop. And Hadoop efficiently handles sequence file. So at any point of time, you can read a particular small file from a big sequence file. You don't have to unzip the whole file in order to read a small file which is packed inside a sequence file. So that is the first step. First step of handling too many small files in the HDFS is by by concatenating all these files into something called a sequence file format. We will cover it when we talk about MapReduce. Okay, now in case you have got humongous file structure, okay, and there is no way to combine multiple files into a single file, then you might have to go for something called HDFS federation. Again, it came in Hadoop 2.0. It came in Hadoop 2.0, and it supports multiple name nodes. Okay, in case, and also the benefit of having multiple name nodes is sharing the load with multiple machines. And the way it happens is we maintain something called mount tables. The client library is responsible to maintain the mount tables. Okay, so client library will read from config that which folder belongs to which name node. Okay, which folder belongs to which name node, and accordingly route the request to the corresponding name node. So a mount table is a list of folders saying slash user is inside name node 1, and slash user 2, slash user 3, and everything else is inside name node 2. Okay, so mount tables is a list of folders with name node mentioned against their name. All right, so for example, in this diagram, you can see that a request for my data 1 is routed by client library to name node 1, and the request to my data 2 and my data 3, these two folders is routed to name node 2. And in ideal world, if I'm running this, I will have two name node having two different standby node. And the other important aspect to think of is to ponder, to think about is this pool of data nodes. This pool of data nodes is common for both the name nodes. So name node 1, name node 2, utilizing the same pool of data nodes, storing their blocks, okay, and utilizing the same disk space, because it's not the data node which got became the bottleneck, it is the name node which became the bottleneck. Therefore, federation allows multiple name nodes to serve the folder structure by utilizing same pool of the data nodes. All right, so this is the HDFS federation. All right, okay, I hope this is clear to everyone. So this mount table looks like something like this. Mount table will look like something like this. It'll be okay. This goes to 192.168.1.34. Okay, and my data 2 would go to 35. This is our name node 1 and name node 2. Similarly, we might have name node 3 going to all these requests going to name. So this way, at the mount tables label, we could configure here. Mount tables will read this config from the HDFS configuration, and this is basically client library. It's not a server which is running. So if there are multiple users coming in, there'll be multiple instances of client library running in the memory and then talking to different name nodes. All right, all right. So there's question is, okay, so the recording will be available after some time, after few hours, and I like to clarify this. This is important. So recording is generally available here. Is my voice audible to everyone? Great. All right, so the recording will be available. If you go here, if you go here, you can see that this is where the recording will be available. I'll not be emailing you. The recording will be here. All right, so everybody else is able to hear, and okay, I'll make sure that I figure out a way, just that we do not send an email on updating the video recording. Let me try to fix something so that I can inform you all. All right. All right, great questions. And let me move to another question. All right, so a question from uh, Can we have multiple subfolders within one name node? Yes. Is it not that we just replaced name node with mount tables and have the same issue of failover? Okay, let me just think about it. So is it not that we just replaced name node with mount table and have the same issue of failover for name node applies for mount table? In other words, is there a backup of mount table? Good question. I'll try to just clarify this, Anand. So here, let me try to show you how would it look like. If there are multiple users, there is one user, this one, okay, like this, and there is one user, okay, talking to maybe you, okay. There could be another user, okay, having separate instance of mountable, because this is a client library, it's not a service which will become the bottleneck. Every time a user would come, they will start this program and start using name node. Okay, so generally the client library or the mount table will not become the bottleneck. It's not a service, instead it's just a program which the user will start. All right, very good question. I hope I've answered it. In what kind of situation we go for federation with multiple name node? Usually there will be one name node and multiple data node in Hadoop. Yes, that's right. In the so second part, I'm answering that yes. The kind of situation is when file system is very huge. Okay, when there are many files and many folders, in those circumstances you go for multiple name nodes. Okay, the question from Vishnu is mount table the master name node? No, it is it is just it is just a feature in client driver. It is just a feature in the client driver. Okay, question from Suraj is, if a name node goes down and a backup takes place, would another backup be created for this name node? Which part of the Hadoop architecture handles it? Is it HDFS? Okay, so quick answer to you. Very good question first. Quick answer to you, no. Creating a fresh new backup or fresh new name node takes manual intervention. Okay, so it's the job of administrator to create a fresh one. If the previous name node comes back, it will be assumed again, the process will be assumed, resumed. Okay, so if the old name node which went down, it comes back, it will be accepted as a name node, but a fresh new name node creation takes time, and it requires the human intervention. Somebody has to install a name node and then make some other computer as the name node. Okay, all right. Thiru's question is, if we say mount tables are specific to a user, does it mean user 1 cannot access user two's data? They can. Okay, I'd like to show you this one. When I say user specific, okay, it means, say, you and me come to a machine, remotely log into a machine, both of us can say ls. Okay? Both of us can say ls, and what does ls do? It gives us the list of files. Okay? So, all the users who log into this system can run the command called ls. So ls is not a single memory. There are many more instances of ls. But the data, the configuration of ls might be common because all the instances of ls or all the instances of a program are accessing the same config location. Alright, so similarly, the client library is a binary, is a command, is basically not running and not consuming the memory all the time, or it's not a single instance. Every time you run the client library, it will find out where are the mount tables, and whenever you say, whenever the user says client library, give me the files in slash my data. Okay, client library will check in the mount tables that should I talk to name node or should I talk to name node 1 or name node 2. Okay, this is a process. So for every user, client library process will be executed, but all of them will read the mount table configuration from the SDFS centralized configuration stored in a common configuration folder called /etc/Hadoop and HDFS. Okay, so that's that's the definition of mount tables. When we will decide which architecture we are going with, can we change architecture later, or if so, how hard is it? Actually, it's pretty straightforward. You can go with a normal architecture where you have only one name node. Okay, and later on, so as step one, you could go with one name node. Later on, at a later point of time, when you require the backup of name node immediately, you could have standby name node. Okay, and someday, some other day, you might go for federation when you realize that the one name node is not sufficing. It's just that before federation, you will have to separate out the data. Okay, what is SB1 and SB2 blocks on SDF? I'm sorry, okay, let me try to explain it. So these are standby node. These are standby node of name node. The way we had described, every name node having a standby, so that in case name node goes down, this standby takes over. Okay, this standby takes over. In the similar manner, we have name node, first name node and its standby, and second name node and its standby. Brilliant, brilliant set of questions. I hope I am able to answer the question. Please feel free to ask again in case I've missed any question. All right. So these ways. All right. A quick look at what is name node metadata. Metadata is so the metadata is kept in the main memory. Main memory as in the RAM. And what is a RAM? RAM is something, if you turn off the PC, the data inside the RAM would disappear. While it's not permanent, the RAM is not permanent. While and the data on the disk is permanent. And from time to time, the file system paging would be there so that the metadata is kept in the file system. Okay, although so that in case the computer turns off, there is a copy of the metadata available in the disk. And the name node contains this information. So the metadata, when we say metadata, what does it mean? It means list of all files. Okay. So list of all files means the name of the folder, parent folder and its parent folder and so on, and the name of the file and so on. That's and all the files and all the folders. That is list of files. List of blocks for each file. What are the blocks? Block 1, block 2. What are their IDs? Every block when it's cut, it generates an ID. I'll show you where is it stored. Okay? List of data node for each block. List of data node for each block, because each block might be copied to 3 or maybe more or maybe less data nodes. And for each file, the attributes like access time, replication vector, file size, file name, and directory name will be stored in metadata. Okay, so that's part of metadata. And the other part is transaction logs. Transaction log as in transaction log stores the file creation timestamps. When was the file created, deleted, or created or deleted. All of that comes into the transaction logs. Okay. Yes, Ashok, you have a question for me? I can see your question. Are you able to hear me clearly? Okay, a question from Rajiv is, could you please cover the access policy part, or is it in the later part of the course? I mean, how do we define the access policy of the data? Who has access to which data? Okay, I load the data. Now I want to give the access to the multiple users. The access is exactly like your Unix file system. Okay, it's good that you have reminded me. Okay, is exactly like Unix file system. You have users, you have roles, and you have permissions of RWX. Okay, so roles as in groups. Okay, I'll not confuse it. So like for example, me and you both are part of a group called KBD in the file system. Similarly, and therefore you are allowed to access the data in slash data. You are not allowed to access the data created by other instructors like no big data. We have done that kind of thing so that only user will be only able to access either my folder, my users as in our KBD users, no big data users will only be able to access my folder and their own folder and slash data. Okay, and that's based on who is allowed to do what exactly on the Unix file system. If you are aware about Unix file system, then the whole thing will become really easy for you. So you create a user in HDFS, and then you give the permission, you give the roles to the user. So users are part of roles. Okay, a file has number one something called permissions, meaning uh, what can owner do? Okay, what can group do? And what can the others do to the file out of read, write, read, write, and execute? Okay, and a file has permissions, and file has an attribute called owner and group. Okay, so when we create a file has one permissions who can do what, and file has something called an owner and something called a group. Okay, and user is user has groups. Sorry, user is part of many groups. Okay, exactly the same way as Unix file system work. I would strongly recommend that you go through Unix file system once and everything else will fall into place for you. Okay, and user can create a file. All right. So I think once you go through the Unix file system, that will be much more clearer. If required, I can give a crash course on that, but I have not prepared anything as of now. All right. And how often standby name node gets updated to stay in touch with the actual name node? It's done in real time. Question. There was one more question. Okay. So Arun is asking a question about this. This is a very important question. And as opposed to our common understanding that whenever we want to keep a backup, we will do it periodically. As opposed to that strategy, every change which happens at name node immediately gets transferred to the standby as well. So that there's always a copy at standby. And it should immediately reflect at standby. There should not be any delay. There should not be any delay. So Parvez's question is, SBN and standby nodes and name node can be on the same machines or different machines. Ideally, you should always have them on different machines. Okay, why? Because the objective of standby is to be a backup. In case that machine is damaged, you have somebody to take its place. Okay, if both are running on the same machine, it's going to be a disaster. All right. Therefore, although you could trick the system to keep these standby and name node on the same machine, but you should never do that. All right. Ashok, I am sorry, I'm responding to you late because there are many questions which I am reading from top and answering. All right. So, question from Suraj is, will transaction logs be in the RAM? No. Okay. So, they won't be in the RAM. And hence deleted file will also not be there. The only way HDFS is keeping a little bit safety for you that when you delete a file from HDFS, it keeps it in another folder called trash. All right. Now there's a question from Suraj. So question from Suraj is, please can you explain again the part about metadata, file system, and on-demand paging? I think I'm missing something here. If metadata is stored in RAM, how does name node determines the metadata once it is switched off and then switched on? Okay, and won't creating metadata for all data nodes be a time consuming and resource consuming process? Brilliant question, I must say. So let me just take a step back. So the name node is keeping everything into the RAM, and periodically it pages the data to the disk. And so it's like general the way if you have noticed the accounting, periodically the whole account is regularized, and whatever change happen, they will be maintained in a separate register, and so on. Since name node is high performant, therefore every new record, if we try to update the image in the disk, it's going to be real, it is going to slow down name node. That is why what name node does is, as soon as it receives a change, let's say you deleted a folder. What does deleting a folder mean? Deleting a folder means delete the entry of blocks. Let the data be lying around there. It doesn't matter. Okay, as long as data nodes are informed that those blocks are removable. Okay, so so mainly when we delete a file, we basically remove the entry from metadata. So instead of rewriting the whole metadata into the disk, what name node does is it makes a log entry, edit log entry, saying this file got deleted. Now, next time when it creates the file system image into the disk, it will merge the edit log into the file system image. Okay, so question from him is, what if name node is rebooted? What if name node is rebooted? Where will it get the metadata from? And his next question is, if it's trying to compute the metadata based on the old image of the system, and combined with the edit log, as in this was the image taken, a snapshot of the image of the memory taken at 2 a.m., and then these are 500 changes that occurred after 2 a.m. Wouldn't that take time? Yes, that would take time, and therefore every time a name node is rebooted, it takes long time to come up. Okay, so your hypothesis is correct that when a name node is rebooted, wouldn't it take too much time? Yes, it's a time taking, it will take a lot of time to come up. All right. Now Sukhvinder's question is, I hope I have answered your question. Okay, Sukhvinder's question is, since standby name node on the other machine, and if that machine goes down, how will it handle that? Okay, so standby. Okay, so question is, how does this switching happens? Okay, generally we have somebody called zookeeper. Okay, somebody called zookeeper. We will talk about zookeeper in one of the sessions. We basically focus a little bit more on zookeeper. Okay, we call it zookeeper. And zookeeper has this great ability to keep track of these name nodes. So okay, so end user generally would come to the zookeeper to ask about what kind of nodes are available. Okay, what kind of nodes are available. So here zookeeper keeps track of both of these. All right. So end user always comes to zookeeper, and zookeeper itself is a very highly available and a very fast system. Okay, um, as we go into the detail of zookeeper, we will discuss how zookeeper is so fast and is has the ability to tolerate the failures. Okay, so end user talks to zookeeper, and zookeeper keeps on switching between name node and standby, while data node would keep track of both of them. Make sense to you? All right. So for now, this let it be there for maybe a future users. Okay. All right. So that's about the name node secondary failure. Now I would like to give you a little experience on hands-on. All right. Let me just go through a few more questions. Wow, we have some more questions. Okay. Question is, if name node accidentally restarts, what happens if paging of the data does not take place? It will take time. It will basically use the edit log combined with the image. Even if there is very old image, it will take that image and will start combining edit log and reach to the current state. Okay, that's how it works. Okay, question from Sukhvinder is, does that mean data nodes also talk to Zookeeper? Generally, data node keep track of name node and data node via Zookeeper only. Okay, so all the data node also talk to Zookeeper, discover the name node and the backup name node, and then keep on updating that. Yes, and generally this mechanism is called quorum. Okay, you can have multiple backup nodes as secondary. If you want one more backup for this name node, you can have that as well. This is called having quorum general manager. Okay, so that answers Vishnu's question. That was Vishnu's question next. I did not notice that. Brilliant question. So I'm able to see I'm able to see that I'm able to convey what I want to explain. All right. Question from Ashok is, metadata is stored in RAM and disk. So once it reboot, it will get data from disk. Yes. Okay. So that's right. So when you restore, what will happen is it will basically it will basically read the data from disk. So in the disk it stores two things. One, an old file system image. So whenever you took a backup, it will keep the image. And every time it receives a change from an end user, it makes an entry into the file system. Okay, as a like this change happened, that change happened, and so on. The way a log of a process happens. All right. So that was a good question. Now, so when the name node deletes the entry of a file, what will happen to the actual file which is stored in the local or data node which is of the same 100 MB? Is it like garbage collection? So it's like file deletion. So blocks are basically nothing but small files stored on data nodes. Okay? And the file will be deleted. Anand's question is, if secondary backup name node goes down, Zookeeper creates another secondary backup name node? No. Okay. It just removes it is only less. Let's say the secondary name node went down. This went down. Okay. This went down. So in Zookeeper is nothing but like a big whiteboard on which name node keeps writing its name that hey, I'm here, while standby also keeps writing their name. The moment any of them stops writing their name, after a point of time, Zookeeper removes their name. Okay, if they don't keep refreshing, zookeeper will remove their name and will say that, okay, standby has not reported for some time, that means standby is dead. That's it. Zookeeper does not do anything other than behaving like a common whiteboard. Highly available coordination service. That's what zookeeper is. Okay, so in case any of the secondary name node goes down, it is the administrator's duty to create another secondary name node. Okay, so Vijay's question is, how is zookeeper and client library from HDFS Federation exist? So this client library talks to zookeeper. Okay, let me correct it a little bit. Okay, so I'm a little poor at drawing these things. So I'll just try to explain. Okay, so it would look like this way. So this is a client library. This is a client library, and this is the end user. Okay, so what you can do is with the, yeah. All right. So end user talks to the client library talks to the zookeeper, and zookeeper key maintains a kind of a registry of name node and standby, a fresh registry. Every now and then, zookeeper keeps on deleting it unless somebody refreshes their names are deleted. Therefore, zookeeper has a fresh list of name node and standby. Okay. A question from Asok. During the delete operation, if one block is not responding during a delete operation, if one node is not responding, then all right, this okay. I need to understand. So in case we deleted a file and this change is being propagated. So what does deletion of file includes? Remove metadata. Okay. Second, inform data node about deletion. In case one of the data node containing the block is not responding, it doesn't matter. Okay, because when this data node comes back into play, its changes will be updated by other nodes with the transaction logs. Okay, so that time the file will be deleted. In case it doesn't come up, it'll be anyway ignored, and when you put a new node in the network, then it'll have the fresh data. Great, good set of questions. All right, now let's go over how does an HDFS looks like. Is everybody able to see the login password here? Were you able to log in? So, all right, so everybody has access to my courses. Under my courses, you will see Big Data and Hadoop 6 Fab, and these times are for with respect to IST. And here you could see your login password. It's different from what you have for LMS. Okay, this is for CloudX Lab. Now, the first service I would like to introduce to you is Ambari. Then we will talk about HDFS. Okay, so what is Ambari? Ambari is let me log in into it. I'm logging in as admin. Okay, so that I can show you a couple of more features. All right, so what exactly is Ambari? Ambari is a software which helps us install various components of Hadoop. So before you start installing Hadoop, what you do is you buy this hardware, okay? You buy the hardware and then you install operating system on it, same operating system on all of it, And once you have installed the same operating system on all of this, the next thing you do is you establish, you install on one of the machines Ambari server. And on all the machines we install Ambari agent. Ambari has nothing much to do with Hadoop other than helping us install Hadoop. The other way would have been that we would install Hadoop on all the machines. We ourselves will install Hadoop on the machines and then do all kinds of config on every machine. That kind of problems are solved by Ambari. All you have to do is install Ambari agent on all the machines and install Ambari server on any machine. Right now, we have installed Ambari server on H1. Okay, we have 5 machines, H1, H2, H3, H4, H5 right now, and we keep on increasing number of machines from time to time. Okay, so we use Ambari for installing our cluster. In the beginning, there'll be nothing here. It'll ask that on how many nodes you want to install Hadoop. You select the nodes, you say, I want to install Hadoop on these 5 nodes. On this node, I want name node. On this machine, I want data node. And this machine, I want rest of the services of Hadoop. You can see in the left hand side, these are the services which are there on our cluster. You have HDFS, MapReduce, Yarn, Hive, HBase, Pig, Scoop. These are the clients. You see, these are not the services. These are the clients. These are the commands that have been installed. These are client only. These are not running. These are not running. These are just, you know, what do you call passive commands. Whenever you want, you run pig and it will execute. Zookeeper is running, Falcon is running, Storm is running, Atlas is running, and all of these are running. We have Spark and everything. If you want to add one more service, you can do that. Let's say you came up with more hosts, you can go to add host here, and then here you can say add new host. It will ask for this wizard where you will enter the host name. You will copy the SSH key. SSH key is like sharing the password, and then we go next and then select what all services we want to install on that machine, and this Ambari would be able to install all those things. All right, by hardware do we mean just the hard drive, or so Anand's question is, by hardware do we mean just the hard drive or that included? So hardware means everything. So we acquire hardware, meaning multiple machines. So here you can see how many hosts are there. There are 5 hosts. Okay, you can see that one host is having 16 gigabyte RAM, while other hosts are only having 8 gigabyte RAM. Okay, also notice the average load and other these are the local IP addresses of the machines. Make sense to you? All right, now these are the services. If you want to see each individual service, let's say we select SDFS. So right now we have name node and secondary name node. We would be moving to standby very soon. Okay, we would be able to see here and say what do you call enable name node high availability. If we click on that, it will start the standby. Okay, we'll be doing that quite often, quite soon. Okay, right now it's only name node and secondary name node. High availability is not on. There are 5 data node, which means data node is stored on all machines. Okay, and you can see the name nodes. These are the services running on the first machine. All right, Great. So this is a quick way of looking at the cluster. This interface called Ambari is generally for sysadmins. Okay. Now the one which you will be using is either Hue. Hue is a web interface to interact with Hadoop. Okay. Hue is a So Anand's question is, does Ambari comes with Hadoop package? Yes. It downloads Hadoop and installs Hadoop for you. Yes, Ashwini and Maimuna. You can type the questions in the questions window. All right. Now let me show you a very interesting thing. So Hue, when you click on Hue, Hue is the interface that you will be going to use more often. Okay. Why? Because it gives you all kinds of interface. You can talk to Hive, you can write queries for Pig, you can write queries for Spark, and you can also design a Uzi job, and you can talk to HBase, you can see Zookeeper, and you can use Scoop for from here in the UI without going to the command line. Okay, now let me show you the HDFS. HDFS is file browser. You can see inside the file browser. All right, you have for the file browser, you can see that there are too many files. For you, it might be completely empty. Okay, for me, these are the files existing in the HDFS, and this is the folder in HDFS. So the folder information is stored in name node or data node. Quickly, correct. It is the name node. Brilliant. All right. So this is a good way to interact with HDFS. It provides you this beautiful UI from where you can upload data as files. If you uploaded zip, it will automatically unzip it, and you can also create the new folder or new file. I clicked trash folder by mistake. So you could say create new directory or file, and then you can also search here. You could just say A, and it will search all the files containing A. Okay. Also, you can directly go to a particular folder. The data for you is stored in this folder called data/data, and for various tools, we have put all the data at a central place. Okay, we've installed all of this data is read only. You cannot modify it because all the users will be using it. Okay, you could always click home to go home. Okay, so right now, this kind of folder structure does not exist on any of the machines because this metadata, this folder structure is just inside name node. Okay, so so this is, let's say this is one file. This is one file containing hardly 1 byte. Okay, this file is actually one one block. Okay, and so on. So this is the way to create a file. So you could also upload data from here. All right. Let's try to see the things from console. All right, let's open the console. either you could do Either you could open a web console by clicking here, or you could also do SSH. Okay, if you are okay, if you could go to the terminal, you could also say SSH, and then SSH is a way to log in into a remote server so that you virtually reach there. Right now, I'm trying to reach to CloudX Lab H5. So I'm saying SSH Sandeep Giri 9034 at h5.cloudxlab.com. Okay, it's asking for password. I copy the password and paste it. Now you can see that I have actually virtually reached that machine. And also don't get confused between LS, because LS is showing local file system. It's not HDFS. I am actually got transported to H5. Okay, H5 has its own file systems. All these machines also have their local file system, as well as they have a centralized file system called HDFS. So we could talk to HDFS using Hadoop fs minus ls. Okay, you can see that these are the folders which are coming from HDFS. Okay, so we could create a file locally. Let me create a file called 6fab, and I'm using VI. If you're not comfortable with VI, you could use a, something called nano. You can say nano 6fab. Ouch, it does not exist. I will install it later, or let me just do H5. I'm logging from an account which has the superpower. Okay. All right. So I'm actually E and H5 is the same thing. I will say sudo yum install pico and nano. So I'm just trying to install some software for you. All right. Now you have nano 6fab. In here, this is my data. All right. Right now, when you say ls, you can see 6fab file created here. This is my file. I can say cat means printing the data, what is there inside 6fab. Okay, this is my local file in this H5. Local as in this machine in called H5. I'm right now logged in into H5. This is its local name. Okay, local internet name. So you can see that we've created a simple file, but when you say Hadoop fs minus ls, you won't be able to find where is this 6fab. Is 6fab somewhere? I don't think so. Right now 6fab is not there in the HDFS. So okay, again, let before I move forward, when you say ls, you are talking to the local machine. You're not talking to Hadoop right now. The way to talk to Hadoop is either you use this hue, okay, to query the files, or you use a command called Hadoop here. And Hadoop has got many commands. One is fs to talk to file system. Second is jar. When you want to execute your MapReduce logic, then you use Hadoop jar. So if you say Hadoop fs, okay, it shows you all the possible commands which are part of Hadoop fs. So you will say Hadoop fs change mode, change owner, change group, checksum, cat, and so on. There are so many things available. Right now, let's upload our local file. Okay, and to upload a local file into HDFS, we use either move from local or copy from local. So right now we are saying Hadoop fs, please copy my file from local to HDFS. And we say 6fab is my file. Now, when you refresh it here, the file has been copied to HDFS. You can see that 6fab has come here. Okay, this is my data. See that? This one is coming from HDFS, and this one is just this local file. If I log in into H4 or H4, let's say I go here and say h4.cloudxlab, okay, here, all right, it's not configured. Let me just say H4, what was that port? I forgot, 8000. No, it's not installed. I forgot what was the port I had installed. Not this. I forgot where I had installed the console. All right, never mind. So I could also do SSH here. Let me exit from here and say, instead of E, I say D. D is H4 and E is H5. Okay. Now, if I say ls here, there is nothing in there. There's hardly two files. While on E or H5, when I say ls, there are so many files. Okay, but if I say Hadoop fs minus ls from H5 or H4, the file list will be same. I could say Hadoop fs minus ls because H4, H5 or whatever host we have, the Hadoop fs command is talking to name node and giving you the list. Now you can see, I'm sorry, I've logged in into a different account. Let me log in into a different account, same account as here. Okay, you can see that. I'm not allowed to log in into H5. All right. Actually, I'm not allowed to log in into H4, H3 from my usual account. Okay. So, but what I want to demonstrate is this: when you say ls, you see this big list of file. It is not in HDFS. It is only on this H4, H5. It's not anywhere else. While Hadoop fs minus ls talks to the same name now. All right. So one more thing I wanted to show you. One, if you want to copy some file from the server. All right. A quick question to all. This command gives us the list of all the files in HDFS called Hadoop fs-ls. Okay. So this command talks to a name node only, B name node plus data node, C only data nodes. Yes, A, B, or C. Which one do you pick? Brilliant, brilliant. All right, all right, all right. Good. All right, Arun, I'll just try to see if I can help you in any way. Let me try to go back and discuss with all the team if they want me to give a crash course on working with the command line. Okay, although you can get everything done from the Hue UI, but I would strongly recommend that you get a little bit hands-on on the terminal. Okay, good. So all of you are agreeing that it will be a name node. Brilliant. All right. There are a few more questions. Let me take up those, and then we can. All right. So first question from Prashant is, I'm not able to log in into console. Okay. Please note that one, when you log in into this console, okay, say web console, sometimes sometimes when you copy paste the data, it may not work. Second, when you type anything in password, it doesn't move any cursor or it doesn't show any asterisks. That's a standard practice in Unix, not to show anything while you're typing the password. Okay, so in case your login password is not working, click on show and then try typing the password directly by looking at it. Maybe it's because the copy paste is not working. All right, do not panic, because here when you are typing password it won't display asterisk or anything. Okay, so at that point there is nothing to worry about. All right, Rajiv. The next question from Anand is the command different if Hadoop is installed on Windows? No, because it's the same Java which is there in Unix. Here also is the same thing. All right. All right, next is a question from there. Okay, a question from there is, you see, one thing I did not get is that if I'm setting up this architecture for an organization that is not using Hadoop before, how do I do the installation? How do I set up all the components? You don't have to worry about setting up individual component by yourself. You leave that to Ambari. Okay, you leave that to Ambari. So you select one node, first node, install Ambari and Ambari server, okay, and rest of the nodes install Ambari agent. Open http / ambari server host colon 8080, and then this ambari this url will take you through the ride, will ask you what are the host that you want to install Hadoop on, which component goes on which one, and rest of the installation, downloading all these components, installing all of these components, will be taken care by Ambari. Okay, I'll share with you the URL for the installation. Okay, I'll share with you the URL for the installation. Okay, all right. A question from Arun is, this part of session dealing with Hue and terminal is totally confusing for me as I have no knowledge for Unix Linux. So I think what we should do is we should have a session on Unix a little bit. I can take you quickly through the basic Unix terminal commands, okay, so that you get comfortable. Because let's understand one more thing, that most of the technology, specifically in the domain of big data, is going to be server side. And when we deal with server side, it's actually most important to be able to use SSH, terminal, and all these commands. Only then you'll be able to use the server side technologies efficiently. Okay, so If you want, let's schedule a crash, say, let's schedule um, maybe 3 hour session on on the Linux and Unix. I'm completely okay to do it even during the course, like on the next Saturday. If you guys are okay, I'm okay with next Saturday. So Ashwini is saying yes. All right. So let's do that on next Saturday. In the meantime, just go through the basic Unix commands, and I would be more happy to take you through the complete cycle of using all of this. All right. All right. Looks like everybody is good for next Saturday. Just that, we will target. Just that we will target maybe 1 hour session. Okay. Uh, okay. That's what Abu is suggesting. I think that's fair enough. I think 1 hour will be good enough for you to get started. All right. They'll give you a good confidence. All right. And in the meantime, if you want to connect, okay. Arun, if you want to connect and discuss separately, please feel free to drop me an email and we can discuss it. All right. All right. This is okay. So Arun is saying that he's not able to click on the file browser in Hue. This is actually sometimes queer problematic in UI. So you take the cursor from below. That line here should be clickable. Okay. Otherwise, you try to use some other browser. Okay, maybe Firefox or something. Sometimes it does give a problem. There are some more users which have complained, but this is something which is provided by Cloudera, and maybe I'll see if I can fix these bugs. All right. Asmit's question is, please also tell configuring Hadoop without tools like Ambari. So Asmit, that will be difficult in this session because this session is more about using Hadoop than installing, because that Hadoop installation itself is a big deal independently without Ambari, and therefore it'll be not possible in this session. All right. Okay, Rajiv is saying that I get messages for three failed logins. How do we reset it? Okay, so can you just drop me an email at support at nobigdata.com? Okay, with anything to do with any problems, just drop an email to support at nobigdata. Vijay's point is that if you have a recorded Linux session, you can add to my courses. I would love to do that. I love to do that, but I'm not sure if I have a clear session. Okay. Yes. Abu, can you just drop me an email with this because I might forget this. Okay. And I may not know your email ID. So just drop an email to support at no big data with anything. All right. Great. Rajiv's account is working. So when Prabhu is saying that, okay, when I do Hadoop fs-ls, you are not seeing any data because there is nothing in your own account. But if you say Hadoop fs minus ls and then provide a parent folder, then you will be able to see this. Also, if you try to do Hadoop fs minus ls slash data, you'll be able to see the data which I showed you. Also, try to go through the hue and compare the results of Hadoop fs minus ls. All right. What is the link to the system from our, okay? So, all right. So if you go to no big data, were you able to go to my courses? Were you able to log in? There would be a login on the right hand side. Okay, there will be login on the right hand side. The okay, the place where it's showing my points. Okay, the my points are rewarded based on how many quizzes you attend. We have recently activated this feature. So when you click on login and then you go to my courses and then you go to 6fab, do you see here the CloudX Lab details? These details are coming from CloudX Lab. Okay, here you can see that. Do you see this section, Atrey? All right, all right. Stay connected, and I know you will have a lot of questions, so feel free to reach out to us. Okay, these details which you see here are CloudX Lab details. The one which you received in email are LMS details. So one is for nobigdata.com, and these details are for cloudxlab.com. Okay. So Rajiv's question is, are we already behind schedule? No, we are not. Okay, this is all part of planned. How do I run a command like grep for files on Hadoop FS? Brilliant question, Vivek. Okay, brilliant question. And that's where we will talk about MapReduce. Okay, one way would be MapReduce and Hadoop streaming. Okay, in the meantime, if you want, you can just go through the pre-recorded video which are from the previous session, and you can just go through them, which are already available in LMS for you, and you will get to the speed. All right, great. It was a wonderful session, and thank you very much. I look forward to hear from you at support at no big data, and I look forward for the session on the next week. Okay, so you can simply say, Leela, you could simply say Hadoop fs, and it'll show you all the commands which are here. You see that? Hadoop fs, it shows you all the commands. And in the meantime, you could also try minus help and say ls. You see that? The detail about every command you can see from Hadoop fs minus ls and copy from local. See that? Great. Athri is saying, can you show us how to reach the console? I'd like to show you. If you others also want to see it. So once I have logged in, I see this. I click on the web console. Okay. Copy this login. Okay. And then I copy the password and paste it here. In case the paste is not working, it's giving the password incorrect. Also note that the password may not show. And this is where I have the command line. I can run big command line from here. Okay, good. If you are coming from Python background, you can run Python console from here. You can run PySpark, which is Spark console from here. Okay. So everything you can do from here as well. If you want to run R, you can run R from here. Okay, so that's the wonderful part about this console. So you are virtually on that server doing anything on that server. Parvez is saying that can we have unique session before next class? All right, that's going to be a little difficult. Let me try to see coordination. Let me coordinate with the students. So Anjana will be sending you email about the time slots, and let's see if we can have before the next session. Okay. All right. Today's homework is just go through these quizzes. Okay. Go through the quiz and see what all can you answer. All right. So the terminal which I'm using, either you can use this terminal or you can SSH onto the server. Sure, I'll upload the today's session. Okay. All right. Great. I look forward to see you next week. Bye bye. And in the meantime, if we schedule something in the midweek, I'll let you know. All right. Bye bye. Have a great day. Thank you, Atrey. I'm happy that you're finding it great. Feel free to give me a feedback at the end of session. And all right. Bye bye. Stay connected. Great. It's a great class. I'm totally enjoying it. Bye bye.